Good afternoon, I am Mr. Ish. Thank you for joining me for this video where we are looking at seesaw problems. They're synonymous with lever problems. You've seen problems like that. Seesaw and lever problems are the same. The basic premise is you have a plank with a fulcrum. You have to understand when you have a heavier weight on one side of the fulcrum, to balance that plank or the lever, you must position a lighter weight further away from the fulcrum. If you have a specific weight over here, it is a certain distance from that fulcrum. If you put a weight on the other side and it's lighter, it must be a certain larger distance away, and you can look at everything as this. You have your W1 D1, you have your W2 D2. Weight 1 D1, weight 1 times distance 1 from the fulcrum is equal to weight 2 times distance 2 from the fulcrum on the other side. Again, remember, a heavier weight closer to the fulcrum is countered by a lighter weight further away from the fulcrum. That's just how it works. In terms of balancing the plank means your plank is going to stay horizontal over that fulcrum. It won't seesaw in any particular direction. So let's keep that in mind as we look at two questions in this video. Let's look at this question right here. A boy is positioned at the end of a 13-foot plank. He weighs 80 pounds. Where is the fulcrum if a girl weighing 90 pounds is positioned at the other end of the balanced plank? So we have a plank which is 13 feet in total, and we have a certain boy who's sitting here at this end. We'll call that B. We have a girl who's sitting at this end. We'll call that a G. The boy happens to be 80 pounds. The girl happens to be 90 pounds. If we are told that everything is balanced, where would this plank's fulcrum be? The boy is positioned on a end of a 13-foot plank. How would you go about doing that? Well, the heavier girl must be located closer to the fulcrum. The lighter boy must be further away. If this right here is x, and that's 13 minus x, and that'll give you everything you need to know. You'll have 80 times 13 minus x is equal to 90 times x. All you're doing here is algebraically splitting that 13-foot plank into two different parts. You'll have to do this algebra here. 80 times 13, you're having here a 1040 minus 80x is equal to 90x. You'll solve for x. Take this on the other side. You'll have 170x is equal to 1040, and then x is going to be 1040 divided by 170. That'll be 6.12. 6.12. But what is that really telling you? It's telling you the distance right here, 6.12 feet. And then you can do 13 minus 6.12, and you're getting here 6.88. So what does that tell you in terms of answering the question? Where is the fulcrum if the girl is positioned at the other end of the plank? Well, it depends on which side you're looking from. If you're looking here from the girl's side, the fulcrum is 6.12 feet away from her. If you're looking from the boy's side, then the fulcrum is 6.88 feet away from him, from that end of the plank. But your question has been answered. Your fulcrum is 6.12 feet from the girl's side, end of that plank, or 6.88 feet from the boy's side, end of the plank. Let's look at this last question. We have Joe, a boy, he's 100 pounds, and he sits 2 feet from the fulcrum. How far must Jill, who is 40 pounds, a girl, sit from the fulcrum on the other side to balance the plank? If the plank is 6 feet long, is this situation even possible? Meaning, can the plank be balanced? Well, let's look at the first question. We have Joe, and we have a boy who's sitting 2 feet from the fulcrum. Here's my 2 feet from the fulcrum, and he's sitting over here, and he's 100 pounds. To balance him, we have a girl who's sitting on the other side but a certain distance, and she is only 40 pounds. The lighter the person, the further they must sit away to balance someone who's heavier on the opposite side. So let's look at this and calculate that x. We have 100 times 2 is equal to 40x, and we'll solve for that. It'll give us the distance the girl has to sit from that fulcrum. 40x is equal to 100 times 2, which is 200, and x here is equal to 200 divided by 40. We get 5. So what is that telling you? We're getting here a distance of 5, but we know that the boy is already 2 feet away from the other end. So at a minimum, we need a plank which is 7 feet long. Here we're looking at a plank which is 6 foot, so it's not even a possible situation. The plank would be too short. If you were looking at a 6-foot seesaw, a plank, you couldn't balance this boy who's 100 pounds with a 40-pound girl. You just wouldn't have long enough plank. If the plank is only 6 feet long, is the situation possible? The answer is no. But in general, the girl would have to sit 5 feet away from the fulcrum to balance a boy who's sitting 2 feet from the fulcrum on the other side, having a weight of 100 pounds. So these two questions are answered, and that's it for this video. Have a good day.